Okay, so as you saw in my last video, I showed you how to do a moment by doing the cross product. Um, but really, that's not a really good method of doing moments. And to be honest, either is method two. What I really want you to do in the end is do method 2.5. It's really similar to method two, just a little different. So a little different, but I'm going to show you method two right now. So method two is just the line of action one. So really, if you look at the cross product, so M in the end is just R cross with F, you know. So if you do the cross product, really it's just going to be the magnitude of R times the magnitude of F. Don't forget the vector. Times by sine of the angle in between. So that's just the definition of the cross product in the end. Okay, so now before I continue, I just need to tell you what the line of action is. So the line of action is like if you have your force and you just extend it this way and that way, just make it into a line. That's just called the line of action. So really, your moment or torque or whatever you want to call it, I guess. So anyway, really, it's just going to be your moment. It's just going to be plus or minus, and really the plus or minus is just from the right hand rule, and then so then you're going to have plus or minus, and then times by the magnitude of your force, and then times by the distance to the line of action. So when I say the distance to the line of action, it's not any distance, you know, because this r is technically a distance to the line of action from where you're spinning about, you know. Uh, but what you want is a perpendicular distance. So this is the perpendicular distance. So really, it's just going to be this distance in the end. So this is going to be d. So if that's d, and this is perpendicular right here, really, and we know that this is theta, then this also has to be theta. And so really, our sine of theta is going to give us d, and in the end, that's what this is. R, the magnitude of r times by sine of theta gives you this distance. So really, in the end, you just need to get this distance. So I would have done that with the previous example, but it's just a little too obscure in the end. So like if you basically had this line of distance, if you had this distance to the line of action, it would look more or less like this, and this distance is just like super hard to get, you know, because you don't know what this angle is really. You just don't. You could figure it out, but you know. But yeah, so yeah, this is the distance, but I would have done it like this, but it's just really hard. So for this example in particular, though, your moment. So we'll just say m. You know, is just going to equal. So the magnitude of your force is just 2 right now. So that's just that guy. So it's be 2 times by here, magnitude of the force. And then, so I'm just going to write it out like this, just so you know this is d for sure. So anyways, and then that's just going to be 2, and then times by 4, and then times by sine of 30. So sine of 30 degrees. This is just the half. And so before I end this, I do have to count for this plus or minus. So I'm just going to put the plus or minus right here. So you get the plus or minus just from the right hand rule, like I said. So if I get a circle real quick, put it right at the middle. Okay, so if we have this circle again, really this force is going to want to make everything rotate in this direction then, you know. So it's going to rotate like this. So now if you use the right hand rule for this, and you curl your hand in this direction, your thumb is gonna point outward. So your thumb is gonna point outward, and so you're gonna get a positive value. So it's gonna be plus in the end. So, and you can actually see that when you do the cross product of these, you know. So I would do the cross product real quick, but this isn't in vector form. But you know, so if it was spinning in the other direction, then it would be negative, you know, just because your thumb would point into the page, basically. So this is counterclockwise, so your thumb points out of the page, so it's going to be positive in the end. So really, your moment is then going to equal, so those cancel, and it's just really just 4 Newton meters then. So